All right, I'm good to go. In case you don't know me, I'm Eckhard Groll. I'm the head of the School of Mechanical Engineering, and I now have the distinct pleasure to introduce Professor Davide Ziviani. And if you don't know Davide, I will introduce him as the most non-Italian Italian that I know, because a typical Italian likes Formula One, likes soccer that they play in Europe, but Davide grew up and actually started to love American football, not the European football, right? The American one. He's a big fan of the New York Giants. But then on top, what he likes even more is the NBA, basketball, US basketball. And there he stayed true to New York and likes the Knicks. And I don't know if he has it in his presentation, but there's a photo of him on his wedding day, he in a tuxedo, and Eva was in the room, right, in a wedding dress, and they're on a basketball court, and he's shooting a hoop, right, over her into the basket. That's Davide in a nutshell. He got his first degree in Italy, but wanted to come to the US for obvious reasons, right? He wasn't thrilled with the US. Came to San Diego for his master's, then switched back to Belgium, to Ghent for a PhD program, but was actively trying to get back to the US, got a scholarship, and actually contacted us at the Herrick Labs to come to the Herrick Labs to do part of his research there. And then he never really went back. He was able to stay at Purdue, finish his research, got his degree from Ghent. We hired him on as a postdoc. Then we hired him on as a research assistant professor. Then we hired him on as a tenure track assistant professor. And if you really just use the tenure track time, right, he's probably one of the fastest people getting to tenure at Purdue in engineering. But it's a little bit unfair because he had the additional time up front to get a head start. But I will let him introduce all of his wonderful research. As I'm sure there's plenty in his presentation, but please help me welcome Davide to the stage here.
Thank you, Eckhard, for the wonderful introduction. I don't have that picture that I'm shooting over my wife. I don't know it would have gone well, I guess. But I wasn't sure really what to put on the slides when I was creating this presentation. And then I thought about what would be useful, especially for the students, right? And the party side is on that side there. But kind of tell about my journey, actually, to get to engineering first, then Purdue, and then to become faculty. So as I can mention, I grew up in a small town in Italy, in the plains, not too far away from Venice. That is not a UAV picture of Indiana. That's where I grew up. Maybe it was meant to be, right, to come home to Indiana at some point. But really growing up, there was only a couple of things that mattered, right? Basketball, and then football, right? And so be like Mike, that's not the Gatorade commercial, right? But that's really what I wanted to do. And I played basketball throughout my undergraduate degree until I got to grad school. And really, I could not keep up anymore with 3 practice a week, gym, lifting, games, travels, and all the kind of things. But the other important thing was engineering was not the prime actually for me. I wanted to go to med school. I want to become a neurosurgeon. Engineering was in the back of my head. But my mom, who then became a Boilermaker, of course, she bragged about there's too many doctors in our family, right? Go become an engineer. So long story short, I got the engineering degree. I also became sort of a doctor, I guess, or doctor of philosophy, if you will. But it all started with my undergraduate degree in Italy, University of Ferrara. Two of my mentors, Professor Venturini and Professor Pinelli, really got me into research. And at that time, I was really working on pretty much gas turbine, cooling of blades. That was really my initial research. And then some heat recovery here and there. So I got accepted into a scholarship program at Cranfield, right? If you don't know, very prestigious school for aircraft designs in general. But then I also had an opportunity to do an exchange program at San Diego State at that time, right? Guess where I went, right? In a blink of an eye, I took a plane, went down to San Diego. There, Professor Bayen, gave me the opportunity to build in my very first test setup. It was an organic ranking cycle, waste heat recovery back in 2010. And that really got me into thermal sciences, right? Moving heat around, playing around with thermal systems. And that is also when I met my wife in San Diego. So that's the picture that I have, not the basketball shooting. But then the fun fact was 2010, right? In another side of the country, the HARI conferences were ongoing. And to me at that point, I knew about Purdue, right? Ranking, you look at the ranking scores and other things, but HARI Clubs was popping up as the major source for me for research, really. Papers were available. And so HARI kind of, stayed with me. If you fast forward a little bit more, I moved to Belgium where I did my PhD on the European Union funded project on heat recovery. Michel Depas was my mentor, but at the same time, I was working in colleagues in Liège, Vincent Lemort, and one of the person that really changed my life, I think at that point, was Ian Bell, who's now as a NIST, a former grad student at the HARI class, because he said, there's this conference in London, right? And you should go and you should meet one person there, right? And then there was like a girl. So that's how the story goes. And so I went up to him, introduced myself. I had the scholarship in hand, right? And that's ultimately how I came to Purdue. Fun fact, one of my colleagues, Craig Brashaw, right, that we met the first time in 2013, right? Still friends to date. Those are persons that really shaped my career, actually, and still we maintain a relationship. So when I came to Purdue, met Jim Braun as well, and the Center for High Performance Building got established at that time as well. So I was one of the first round of students working on it. And but more importantly, right, in both times that I came as a visiting scholar, there were a few things that struck me about HARI Clubs that ultimately wanted me to come here, right? One was the community, sense of community, mentorship, and then research opportunities, right? And so at that point, I wanted to do research. Research was really my primary goal. But then I learned about teaching, I learned about mentorship, right? And I think at that point, I did make a decision. Okay, I gotta go to academia. But it was not really straightforward because I became a postdoc, right? And then you need to wait for those search cycles, right, to come out. Yeah, I wanted to stay at Purdue, but you know how it goes. It's tough to get to Purdue, and you don't know when faculty lined up and so on. But then finally I got to the interview round and I got the offer, right? So very exciting. So guess what is the best time to start your faculty career, right? As a tenure track, obviously during a pandemic, right? So 2020 was that year, right, where we had to deal with classroom setting like that, developing operating procedure to even stay in a lab. But that was also the time where I made the right decision. I'm going to hire a bunch of students during COVID, right? Wise thing to do. And also decided to expand our summer course, right? And of course, we had to do it via Zoom. But then GatherTown, right, was our social media, I guess, where we would spend lots of time. And we ran an entire conference over GatherTown. So that was quite entertaining. But that's how I get started, really. If you fast forward now about 3 years and a half, about 4 years or so, now that's where I got to, right? So this is kind of the group that I have right now. This picture is in the spring 24 when I got tenure. There's about 22 PhD students, about 9 master students, on average 8 to 10 undergraduate students every semester, and 2 postdocs that now they moved on. But that's kind of, the progression that I made, a fairly large group. And as you see here on the title, really for me, faculty was having the ability and the honor to impact students, right? And so a bunch of things in there. Still play basketball intramural, right? So we made it to the final, play at Mackey. But really, in a nutshell, that's what faculty job means for me. Yes, you got research awards, all kinds of things, but impacting students is really what drives me. So from a research perspective, what I like to do, in a nutshell, like fundamental and application of thermal systems, right? Anything where it requires heat to be moved, that's what I like to pursue. And so anything from emerging technologies, things like components, heat pump, refrigeration system, anything falls under that category. But also things like thermal management system, like electric vehicle, data centers, right? They're still moving heat to different needs, but still the basic fundamental problem remains, right? Moving heat from one source to another. And then more recently, and I will talk about it in a few slides, but deep space habitats, right, and thermal system in a deep space, that's also an emerging field, right, that I think will stay with us for a while. So I wasn't sure what to cover, but I would like to maybe go through a few examples of research that shaped my career and also are enablers, right, for future work. And one of the first was essentially the very first round of PhD students. There are a few more here and there, but the slides is what it is. So I couldn't squeeze in all of them. But the very first round of PhD students is really where it gets you going, right? First publication, first grants, you graduate, right? And so you really develop a special relationship. Two of them are graduated already. A few more are graduating within the next couple of semesters. And then pretty much there's a new slate of students, right, coming online, which is exciting, but also nerve-wracking, right? Because you got to trust the students. But also at that time was the first time that I got a large award that, is just finished this year. So first $1 million plus award got me through pretty much tenure, right? And we were able to accomplish lots of awards, publications, right? And additional funding opportunity. The other thing that also interested me quite a bit is essentially thermal management systems in general. And we are living in a world where electrification of vehicles, data centers, and things of that nature, right, requires lots of heat, requires cooling, right? We need to move heat efficiently. And so a few years ago, through the Cooling Technology Research Center that Justin Bible leads, we started this work on co-simulation of thermal management systems, specifically for EVs. We built a large-scale model that could capture both what happens at the interface in the battery all the way out to really the entire architecture of the system. We went on also building test setups. You see here some of the grad students, they are either just starting or about to graduate, but this is a hot topic, right? And if you're looking at problems that are interest to me personally, but also that will allow you to grow the research over the next few years, this is definitely one of them. And then very early on in my tenure track, Professor Shirley Dyke, who established the Resilient Extraterrestrial Habitat Institute as a director, she approached me and said, we have this opportunity of working on thermal systems, heat pumps and other things, why don't you, come along and see if there's something that aligns your research. And so Ilias Bialionis was a thrust leader, and he is a thrust leader for the awareness team. And so we kind of worked together to develop a cyber physical testing. We could not really making asteroids fall on Herrick Labs, right? That would not really work very well. So we had to find a way to move things in the cyber world and while having some real hardware in the lab to do experiments. And so myself and several other colleagues, lots of students, right, we conceptualized what was the cyber physical testing. So portion of the system was physically in the lab, portion of the system is completely virtual, right, and we can run this one in the loop. And so when I started, right, the lab was looking pretty much like the picture in the left, was empty. There was a tiny pressure box, simulated an entire habitat, right? And then you fast forward now for 4 years pretty much, and that's now our smart hab. And that's the facility that we have been building and that we're going to be expanding upon. I think this space habitat, space exploration, I think that's one of the growing opportunity for us as an engineers. There's a lot of challenges, a lot of things that can go wrong. And so some of the work that we're looking at, how do we make thermal system resilient? So faults, of course, they're inevitable. You have performance degradation over time. How do you still manage, right, to make those systems keep running, right, and adapt over time? So that's a fascinating topic, but I think this will, will stay for quite some time. Also, during this period of time, had the opportunity to meet President Daniels and also Dean Chang at that time, telling all about what we were doing in the lab. We had a few undergraduate students that started with the Indiana Space Program as well. That was during COVID, so everyone masked up. And also during the 2022 ARI conferences, Vanessa White, who is the director of NASA Johnson Space Center, right, came at Herrick Labs, and we had the opportunity to host it, right? And so we started with research in a lab, an idea, a program, right? And we got all the way up to the command chain pretty much, right? So that was pretty interesting. Now also where are things I had in where research, right? So we're talking about the 3D printing also from the previous talk, right? Opportunities, machine learning, discover new things, right? And so we're trying to do the same thing also in thermal system, right? So how do we make our heat exchanger, heat sinks, in general, heat transfer methods, right? Smart, intelligent, right? And how do we take advantage of advanced manufacturing? So that's some of the work that we are doing. Colleagues Justin Babo and Jess Arrieta, we are working on embedding intelligence now in heat exchangers. So heat exchangers are aware or self-aware of what's going on inside the fluid channel, and that they learn along the way, and potentially they're gonna be able to make decisions right by themselves. And so smart material, meta materials comes into play in this field. So those are a few of the research, right, that I think, probably will get me through, hopefully, the next round of promotion. We'll see. But again, the research is one thing, but teaching, I think, and service are the other two important aspects and pillars, right, to us as faculty. And so I spend quite a lot of time on the teaching side of things. I love teaching, lots engaging with students, lots of activity. And so teaching is one of the ways that we can inspire students. It's not just going through a bunch of equation assignments, exams, and that kind of things. It's more like conveying and being excited about certain topics. And so that's really the first way that we can attract students to grad school, but also getting them excited to engineering. And so throughout the years, I had the opportunity of becoming a national distinguished lecturer as well. So you go around and you give lectures to experts in the field that they listen to you. That's quite remarkable there. But you meet people, you impact students. And so I think this is something that I truly treasure as a faculty. Next summer, we're going to go back to Italy, I think for the first time. So we're going to go to a Ferrari. We're going to go to Dallara, right? So hopefully I get back to some roots, I guess, in Italy. And then mentorship, I think, is the other important aspect for us, right? Really, we're shaping lives of students, right? That's what we are doing in a nutshell. We are touching thousands of students over our careers. And so we are trying to convey being passionate about topics, try to create opportunity for them, right? Develop a critical thinking as well. And so lots of the time that I spent is really mentoring undergraduate students, international students that come as a visiting scholars. And so a few of the recent students, right, that I was able to mentor, they became faculty themselves. So it's also nice to see that transition and then a number of opportunities, right, for learning. So I'm gonna try to keep the time here, but obviously the list of acknowledgement goes on and on and on. So, but definitely, faculty mentors, Nicole Key, Jeff Rhodes, and then Greg Shaver, right, that were really my faculty mentors through the tenure process, and they will be continuing on. The Herrick staff that is always being part of what we do on a daily basis. Yes, I know we're missing a few people here on the slide, but that's all I could do here. And then friends and family, foremost my wife, obviously, that she has been with me throughout the time, even through my PhD. Piece of advice, wife during PhD, right? Lots of time spent on the computer, coding, debugging, writing papers, right? So, but thank you for being there. Then obviously my family, my mom is on the picture. My father passed away 5 days prior my PhD defense, so that was a very tough. But that shaped my life, and excuse me. And also my mother-in-law passed away a few months after, so that made it very tough for us. But you was family, some families here. So thank you. Hopefully this is inspiring for you. Hopefully some of you may become faculty, some not. If you go to industry, right, we need funding, so bring back money to Purdue. So. But thank you for listening, and happy to answer questions.
Thank you very much, Davide. Wonderful presentation, as always. Should have mentioned in my introduction that Davide runs one of the 5 largest research programs in the School of ME out of 95 or so faculty members. And that is kind of my first question, maybe to you for the audience. How do you manage your time, right? How do you get to a program that size? Right, what advice can you give people on multitasking and keeping track of things?
There's two things that you need to balance. Expectation from Purdue, right? Performing, metrics, that kind of things, and my wife, right? The two do not go hand in hand, I can tell you. It's a tough thing because the more you become successful, the more things you get exposed to, the more things come to you, and you're not always in a position to say no. Now I got tenure, maybe I get to say some no's here and there, but it is really tough. I'm still learning. I don't have a good answer, but I did learn how to become very efficient in doing tasks and how do you piece out time really during the day. Unfortunately, we still live on 24 hours, I think. But yeah, I still learning. That's still a progress, not a strong answer there for you.
All right, yes, go ahead.
So I have to ask the controversial question. Who is your NBA GOAT?
The way that I answer to you, I have one poster at home. There's three of them: MJ, Kobe, and LBJ. Politically correct answer?
I mean, I'm a Celtics fan, but
True. I did not grow up with that.
Yeah.
So that's a thing. Yeah. I did go to Larry Bird house though. I knocked at the door, the people that were living there. So and they took us in the back in the barn where they had still the board, right, that was taken down, right, and still there. Yeah. So I did that.
All right, any other questions? Any questions from his students? They're all sitting there nicely.
I know. It's quiet group today.
Quiet group. All right, I'm supposed to close the session today. I would like to thank Davide one more time. Thanks for being here. Appreciate it. So now I give you my impression of Arvind as he asked me to close out. I would like to thank, of course, all three associate professors that we saw today. It's really inspiring. Every story was just wonderful and just very special. And I think what I take from these sessions, and I'm usually here to introduce the ME faculty, but then I listen to, of course, the other faculty that get promoted to associate professors in the college. But what I'm taking from this is really the College of Engineering and then beyond Purdue University is in excellent hands, right? The future is secure. We have just really, really strong talent, really great faculty that do just wonderful work. And so I think the future is bright. And with that, I will thank you all for attending today's session, and we'll close it out. Thank you very much.